Okay, guys, Calculus 3 students, good afternoon. Well, it's the afternoon for me. It's almost 1 o'clock on Thursday afternoon, and this is definitely going to have to be my last video lecture. Um, yeah, my last video lecture for the chapter 13 and 14 homework assignment. Okay, so my goal is to try to get through, let's say, 5 or 6 problems in this video, and that should be sufficient. And if you're having difficulty with other questions or problems in the homework, you can always email me. But also remember, you can look it up in your textbook. You can look at other YouTube videos. Um, you do have the option of help me solve this, view an example, look at the accompanying video, open the textbook, and read about this particular type of problem in your textbook. You can email me. There are things you can do. You can print out the problem, and then you can show it to someone in your family or maybe a neighbor or friend who has studied calculus before. You have options, guys. You have a lot of choices. There are things you can do, okay? So let's get started. So problem 55 is a fun problem. It's definitely a fun problem, and it will probably appear either on your quiz for this section or your test, or maybe both the quiz and the test. So the problem reads, find the volume of the given solid region in the first octant bounded by the plane 5x plus 3y plus 15z is equal to 15, and the coordinate planes using triple integrals. So if this tetrahedron is in the first octant, which it is, we can see that, all of the coordinates here, all the intercepts, are either going to be 0 or positive. Okay. Now, it is giving us the equation of the plane. The authors of the problem, they were very generous. They gave us the equation of the plane. But you should be able to figure out the equation of the plane simply given these 3 points. Okay, so let's see if we can do that. Let's see if we can, I'm trying to squish this down a little bit. Okay, so matrix is equal to, I'm looking at this point right over here. Okay, so x minus 0, y minus 0, z minus 1. And I'm going to look at this point right here, 3, 0, 0. X minus 3, y minus 0, z minus 0. And then this point right over here, z minus 0, y minus 5. Y minus 5, and then z minus 0. Oh, here we go. That should be, wait a second. Yeah, that looks good. Wait a minute, wait. Let me check my points here. So x, y, z minus 1, and then we have x minus 3, y, z, and, oh, no wonder. Ugh, I knew something was wrong. Okay, x, y minus 5, x minus 0, y minus 5, z minus 0. Okay, that's much better. Let's see. Okay, so that's the matrix. So remember, a plane has 0 volume. In 3-dimensional space, a plane has no volume, which means the determinant is going to have to be 0. Now, the determinant is more of a linear algebra concept than a calculus concept. However, Calculus 3 and linear algebra are 2 courses that go extremely well together, and they share many of the same topics. Because in Calculus 3, you're learning about vectors, okay? In linear algebra, you're learning about matrices. Well, what's a matrix? A matrix is really simply a vector made up of vectors. This is a column vector, okay? This is a row vector. So a matrix is simply a vector of vectors, or in terms of Mathematica, it's a list of lists, okay? So let's solve this. The determinant of the matrix equal to 0. Let's solve it for z. And let's expand it. Traditional form. Okay, so then we can see the upper z limit. So we know that the lower z limit has to be 0, and the upper z limit is going to be negative x over 3 minus y over 5 plus 1. Okay, so let's write that down. This is really a little bit squished. Okay, so the lower z limit is z is equal to 0, which is the equation of the xy plane, and the upper z limit is simply going to be negative x over 3 minus y over 5 plus 1. Or if you want, you could put the 1 in the front. It really doesn't, it doesn't make a difference. Okay. I think it looks prettier if the 1 is in the front, but actually, guys, it really doesn't make a difference. Now, to figure out the y limits, we're just going to look at the xy plane. We're going to look at the xy plane. So here we can see the points 3, 0, and 0, 5. Right? I hope you can see that. Okay, 3, 0, and then 0, 5. 3, 0, and 0, 5. So let's consider those 2 points. Oops, what did I just do? Okay, we're fine. Okay. The marvels of technology, right? Okay, so 3, 0, and 0, 5. List plot 3, 0, and 0, 5. Plot markers. Filled circle. Close the square bracket. Maybe 20 pixels across. Joined. I don't want to join my 2 circles. And let's make them nice and black. Okay. Okay, so we can see this point, 0, 5. This point right over here is getting cut off a little bit. So let's extend the range. Plot range in the x direction, negative 1 to 6. And then in the y direction, in the x direction, we can go negative 1 to 4. And then in the y direction, we can go negative 1 to 6. Okay, and that looks a lot better. Okay, and let's make the 2 axes equal in length. We'll make the 2 axes equal in length using the aspect ratio command, which simply means that y is the same length as x. If this was 1/2, then the y-axis would be half as long as the x-axis, right? Okay, which is okay. You could do that too if you want to. Okay, whatever helps you to visualize the problem better. Now let's think about the equation of this line, okay? So we have this point, which is 0, 5. And we have this point, which is 0, comma 3. Okay, so we can see, we know the equation is going to be y is equal to mx, mx plus b. Well, we know b is going to be 5, right? Because whenever x is 0, y is equal to b. Okay, and how do we figure out the slope? Okay, so that's going to be easy. We have 5 minus 0. 5 minus 0 divided by 0 minus 3. And that's going to give us negative 3/5. Negative, oh, I'm sorry, negative, okay, that's going to give us negative, negative 5/3. Okay, so 5 minus 5/3 x. Okay, so 5 minus 5/3 x. 5 minus 5/3 x. X goes from 0 to 3. And the plot style is going to be thick, dashed, and red. And then we're going to show both pictures at the same time. Okay, terrific. So based on what I've done here, we can see that my y limits are going to be 0 up to this line. Okay, so this is the line y is equal to 0, which is really the equation of the x-axis, and this is the line y is equal to 5 minus 5/3 x. So these are going to be the lower and upper limits of y. This is the lower limit, this is the upper limit, okay? And you should be able to see that. So here, the lower limit is 0, and the upper limit is simply going to be 5 minus 5/3 x. Or if you want to, you could put the x on top. I mean, it doesn't really matter. 5x divided by 3, or you could do, 5/3 x. It's actually the same thing, right? It's the same thing, okay? And then here, just by looking at the picture, you can see that the upper limit of x is going to have to be 3. And that should be the correct answer. Okay, so then we just have to, hold on one second. Okay, so then we simply have to figure out what is the value of this integral. What is the value of the integral? Now remember, guys, the integrand right over here is 1. The integrand, hold on one second. The integrand, you don't actually see it. It's not explicitly written, but the integrand is really 1. It's really 1. Okay? So, one second. This is a triple integral. Easy to figure out. Escape d int. Okay. Put my cursor in the middle. Escape d int. Escape. Put my cursor in the middle. Escape d int. Escape. Remember, that's the number 1. It's not explicitly written here. It's not explicitly written, but we assume that the integrand is 1. If you don't see the integrand written, you assume that it must be 1, okay? So first we're integrating with respect to z, and then with respect to y, and then with respect to x. The lower limit is going to be 0. The lower z limit is going to be 0. Well, all the lower limits are actually 0, so that's pretty easy. Okay, and then here, The upper limit is 1 minus x thirds minus y fifths. That's the upper z limit. My upper y limit, which of course you can see in the picture, the plot, the Mathematica plot, you can see that right over here. The upper y limit is 5 minus 5x over 3. Okay. And then the upper x limit is simply going to be 3. Very simple. Now, yes, you could do this integral by hand, but guys, beware. A lot of the integrals in this homework assignment are going to get really complicated. If you do all of them by hand, it's going to take you a very long time to finish this assignment. Okay, so my recommendation to you is that you really should use Mathematica to solve the majority of these integration problems, because otherwise you're going to spend hours and hours and hours and hours performing very lengthy and tedious integrations, and really it's not worth it. Use Mathematica to make things easier, and if you use Mathematica, I'm sure you will finish the homework assignment on time. If you don't use Mathematica, I have no doubt this assignment is going to take you a very long time, and you may not even be able to finish it. So do yourselves a favor, do me a favor, do yourself a favor. Use the software intelligently to help you figure out the answers to the problems. Okay? Shift Enter, and the answer should be 5 over 2. 5 over 2 cubic units. Cubic units. Check answer. Okay, guys, I'm going to do one more question for this video, and then I'm going to have to stop. I thought this was going to be my last video. However, I'm using this new video software, and I don't have a whole lot of confidence in it. So rather than putting 10 problems on a video and then, finding out the video didn't work, the video software didn't work correctly, that's a real waste of time, actually. I'd rather just do 2 problems, and if this video is okay, then later on, I'll pick up where I left off and continue doing some more problems on another video. But yeah, I'm going to do one more question for this video, and then I'm going to stop, and hopefully this video is okay, and I'll be able to upload it to YouTube. Let's do the next question, number 56. Now this question, this is kind of a multiple guess question, and I'm going to really use that multiple guess approach, process of elimination. Okay, so find the volume of the following solid using triple integrals. The wedge of the cylinder, x squared plus 9y squared is equal to 9. Okay, created by the planes z is equal to 1 minus x, and z is equal to x minus 1. Okay, so here, okay, I think they're giving you 4 choices. Okay, I can tell you right now, it definitely cannot be choice A. Choice A for sure doesn't work. How come choice A doesn't work? It doesn't work because take a look at the outermost integral. Take a look at the outermost integral. The outermost integral should have constant limits. It doesn't have constant limits. Okay, so I know choice A simply isn't going to work. Okay, here we see constant limits. What are constant limits? Like -1, +1. Okay, these are not constant limits. And the outermost integral should always have constant limits, especially when you're trying to figure out the volume of a solid. The volume of a solid is an actual number. And if the outside integral doesn't have constant limits, then the answer to your integration problem is not going to be an actual constant or a number. So A doesn't even make any sense. So we know, this is going to be out, okay? Let's take a look at some other possibilities. Well, B doesn't work. B doesn't work because, well, first of all, the Z limit. Okay, so the reason why B doesn't work is because if I look at the outside integral, sure, I have constant limits, so it looks like it should work, but the problem is these limits correspond to the variable Z. These are not the correct limits for Z. The correct limits for Z are the planes Z is equal to 1 minus x and Z is equal to x minus 1. So Z is equal to 1 minus x is the plane on top, and then Z is equal to x minus 1 is the plane on the bottom. So this dy would have to be replaced with dz. Okay, so B doesn't work. I know just by looking at it that it can't possibly be the right answer. All right, so we're going to forget about that one. Let's see. Okay, this one looks really close. This one looks really close, but it's not going to be quite, C is not quite right, and here's the reason why. All right, so I have x squared plus 9y squared is equal to 9. Okay, and let's see. Actually, oh, no wonder those aren't the z limits anyway. But okay, so yeah, C definitely isn't going to work because these are not the right z limits anyway. But okay, forget about that for just a moment. Let's figure out x. Okay, so x squared is going to be equal to 9 minus 9y squared. Okay. And then we're going to have, I see what they're doing. Okay. So then x is equal to, plus or minus the square root of, and let's factor out the 3, so that's going to be 3, one second, I don't like their algebra here, the way they're algebraically simplifying this, but, I see what they're doing. They're factoring out the 9. Okay, I see what they're doing. They're factoring out the 9, and then, 1 minus, let me do it like this, 1 minus y squared, and so that turns into plus or minus 3 square root 1 minus y squared. Now, the thing is, though, they have the minus here on top and they have the plus on the bottom, and that doesn't make any sense. The lower limit should be negative 3 times the square root of 1 minus y squared, and the upper limit should be positive 3 times the square root of 1 minus y squared. So they have their limits screwed up. They did that on purpose to confuse you, and besides, these aren't the right z limits anyway. The correct z limits should be 1 minus x and x minus 1, so dz should actually be right over there. So the only possible answer then is going to have to be D by the process of elimination. Okay? The volume of the given solid is, so we simply have to figure out this integral. Okay, so we simply figure out the integral. And again, guys, I have to emphasize this to you. Use Mathematica. I know, when a lot of you took your Calculus 2 course, you probably spent hours and hours and hours doing integrals by hand, and that's fine. That's fine in a Calculus 2 course. This is not Calculus 2, this is Calculus 3. So the purpose of this course is not to teach you integration. The purpose of this course is to teach you how to apply that integration to figure out solutions to problems in multivariable calculus. So it just seems like a waste of time, in my opinion, for you to spend hours and hours and hours and hours doing tedious integrations by hand, especially when the software is available for you to use. Because otherwise, it's going to take you forever to finish these problems, and you won't finish the homework assignment on time. So do yourself a favor and take advantage of the software. It's really not hard to learn Mathematica. It's not that hard. If you can figure out how to do calculus, then you're smart enough to figure out how to use Mathematica, okay? All right, so escape, dint, escape. Put my cursor here in the middle. Escape, dint, escape. Put my cursor here in the middle. Dint, okay, escape. Okay, again, make sure that number is 1. You don't actually see that number, but they don't write it for you usually, but that number here is really 1. There's a 1 there, you just don't, you don't necessarily see it. There we go. Okay, so I'm integrating first with respect to, oh, 1 second. Oh, wait. I'm copying the wrong integral. I have to copy this integral right over here. I was wondering about that. Something's not quite right. Okay, so the first variable of integration is z. The second variable of integration is x. The third variable of integration is y. Okay, the lower z limit is x minus 1, and the upper z limit is 1 minus x. And the lower x limit is negative 3. Control 2 gives me that radical sign. Negative 3, 1 minus y to the power 2. Okay. And then 3, radical 2, 1 minus y. And if I want that exponent, that superscripted exponent, it's control 6, power 2. Those are my x limits. And finally, the y limits are going to be negative 1 and positive 1. And what is that volume? Okay, that volume is 6 pi. 6 pi. Okay, all right, guys. I really should do more problems for you, but I don't have a lot of confidence in this video software that I'm using. And I don't want to do like 10 or 12 problems and find out that all those problems, were erased or never got recorded. That would be pretty horrible. So let me just stop now. Hopefully this worked. Hopefully I can upload this video to YouTube and send you the link or the URL, whatever you want to call it. And if it works out okay, then maybe later today or tomorrow or Saturday, I will prepare another video for you doing a few more problems in this particular homework assignment. Okay? All right, guys, I hope that these videos are helpful to you, and good luck with your homework, okay? Let's pause. Let's stop this. And okay, I think this video is working out okay. It seems to be working. Maybe we can let's do one more problem. Okay, let's just do one more, okay? Maybe I think this video software actually is working okay. Let's try to do one more problem. Let's do something a little bit later on in your homework. So hold on 1 second. Okay, this is a line integral, and I think some of you, I don't know if you've studied line integrals before. Probably not. Probably not. They're very similar to regular integrals, but instead of integrating over, you know, how can I say? Hold on, let me turn on my pen. Okay, normally, in calculus 2, you're simply integrating over the x-axis. Okay, you're integrating over the x-axis. So you have a curve, and you're integrating over the x-axis. But here, you're integrating over a path, over a curve. Here, you're actually, I have some function, right? And I'm integrating this function with respect to a path. Okay, so instead of integrating over the x-axis, now I'm actually integrating over, a line, a curve, a path. It doesn't have to be the x-axis or the line y is equal to 0. Okay, so the line integrals actually end up getting turned into regular integrals, but you have to do some tweaking and manipulation in order to make that happen. Okay, so do I want to do this problem or a different? Well, let's finish up with this problem. Okay, we have a lot of line integral problems in this assignment, so we'll just finish up with this one. And maybe, later on or tomorrow or Saturday, today is Thursday, so maybe Friday or Saturday I can do another video for you guys where we concentrate more on line integrals. But again, I don't want to do too many problems in this video because I'm using this video software that I don't have a ton of confidence in. So, okay. So here we go. Evaluate the following line integral. Okay, in fact, am I still recording? Or yes, I am. I'm still recording. Okay. I should just go back to my old video software. I think maybe it was a little bit better, more reliable, but okay. We'll see how this goes. So I have my function f of x and y is equal to 7x squared minus 2y squared, and I'm integrating that over a parametrized curve. R of s is equal to s over the square root of 2. Well, the x component is s over the square root of 2, and the y component is similarly s over the square root of 2. Okay, and s, we see here that s varies between 0 and 3, which is really convenient. They're actually giving us those limits. Sometimes we have to figure out the limits, but they're actually giving us the limits in this problem, which is very convenient. So the first thing I'm going to do is define my function f of x and y is equal to 7. Here, hold on one second. Let me move this a little bit. Okay. 7x squared minus 2y squared. Okay, very simple, right? And then we have the curve r of s is equal to s over the square root of 2. Okay, and then s divided by, or s over the square root of 2. Okay, so that looks, pretty simple. Okay, so what I have to do is, instead of x, I'm going to use the first component of r of s. And instead of y, I'm going to use the second component of r of s. Now for this problem, it's kind of easy because, if we look at the x component and the y component of r of s, both components are actually the same, which makes the problem a little bit easier. But be careful because that is not always going to be the case in every single problem. Okay? So what I'm going to have here is going to be f of r of s, give me the first component, which is the x component, r of s, give me the second component, which, is the y component. So I have 5s squared over 2. That's simple, right? That's very simple. However, when you're doing line integrals, here's the trick. You have to take the derivative of these components. You have to take the derivative of the x component, which of course is 1 over the square root of 2. And you have, and of course here again, the derivative is 1 over the square root of 2. But then on top of that, you need to take the magnitude of that quantity. You need to take the magnitude of that quantity. Now, how would you do that in Mathematica? Okay, it's really not that hard. We have derivative, okay, of some function with respect to s. Please remember, guys, whenever you use this variable, it's a hash symbol, okay? Whenever you use it, you have to also use the ampersand. They go together. In Mathematica, they go together because otherwise things are not going to work well for you at all right? Okay, so I'm taking the derivative of some function with respect to s. Okay. I'm mapping that onto r of s, and what I should get is simply 1 over the square root of 2 and 1 over the square root of 2. Okay, so that's pretty simple. That's easy. Hey, Chachki, just saying hello to my dog. Hey. Okay, so that's easy. Now I have to take I have to find the magnitude, right? I have to find the magnitude. How do you do that? Well, this goes back to chapter 11. Remember when we found, the magnitudes of vectors? Excuse me. Remember when we found the magnitudes of vectors? How did we do that? We used the norm command, norm, comma, 2. Well, that's really easy. The norm, the norm is simply 1. The magnitude is 1. That's unbelievably easy. So here, for this particular problem, what we really have is a definite integral, okay, in parentheses, 5 times s squared divided by 2 times 1. And now, do I really have to multiply by 1? No, you are supposed to multiply, excuse me, you are supposed to multiply by whatever this value is. Okay, so in my case, it's the number 1, which makes things unbelievably easy. Okay, so I don't really need to worry about the parentheses, and I don't need to worry. Actually, you know what, guys? I may need to worry about the parentheses. You should include parentheses in your definite integrals. That's a really good idea. And I'm integrating with respect to s. And if I remember correctly, the limits are 0 and 3. So the lower limit is 0, the upper limit is 3. And what is my answer? My answer is 45 halves. 45 halves. Okay, so this was kind of an easy line integral. It was easy. The reason it was easy was because the magnitude, the norm or the magnitude of my, I believe this is called my tangent vector. The tangent vector is simply the derivative. It's the derivative of each element of your parametrized curve. Okay, so the norm or the magnitude of the tangent vector was simply 1. Okay, and that actually kind of makes the problem, kind of easy. Um, you know, but bear in mind that some of these problems can get a little trickier. Okay, I think that's going to be enough for now. I wanted this to be my last video. Um, However, I'm going to have to make another video for you guys concentrating on some other line integral problems. Okay. All right, guys, I think that's really enough for today. Okay, take care. And let's see, how long is this video? About 40 minutes. I think that's long enough for now. Okay. Very good. We will communicate in the very near future. Take care.